So I think we're at an age with the Earth where mankind is having a huge impact. We call it the Anthropocene. And as a result of that, we have responsibility to take care of this planet. And that responsibility, I think, is really what new liberalism needs to be about. How do we take responsibility? So the responsibility means that we have to be intentional. And that intentionality is very difficult because we don't know how to have the kinds of conversations we need to have or make decisions we need to make about how the Earth is going to be managed. So we used to have a mantra among environmentalists that we would go back to nature. And since we know we're not going back to nature, we have to talk about where we're going. And I think one of the words that I like to describe that is a term that I talk about as renovation. We're always in a process of renovating our homes. And the little pieces of that renovation are the kinds of technologies and processes and interactions that we have to manage the Earth. So we know that when we renovate our houses, we have a lot of arguments, and sometimes marriages break up over renovation. We want to learn how to have the conversation. And deciding on the goals, I think, is less important than talking about them. It's more important that we learn how to have the conversation than we know exactly where we're going. And that conversation used to be, do you want to go back to nature? And people would say, yes, I want to go back to nature. Now we have to have, well, we're not going back to nature. So what are the kinds of things we value? Why do we value them? Where could we have them? How can I trade off what you value with what I value? And having that conversation is really important. I don't think we have that conversation. It's a hard conversation to have. We don't have a venue for the conversation. We need to develop venues for that kind of conversation. For example, I work on geoengineering. If you are going to geoengineer the climate because it gets really bad and you decide you have to do something about it, then there's always this question of whose hand is on the thermostat. What do you decide is going to be the new temperature of the Earth? Who gets to decide? The Russians might want something different than Brazil. So that's a trivialized example, but if you start to consider geoengineering, then I think you are automatically in that conversation and you have to talk about it, which is one of the reasons I think geoengineering is so interesting, because it is one format where you have to have that conversation. So for example, geoengineers say, well, I think we can put aerosols in the stratosphere and we can lower the temperature because we'll reflect some solar radiation and so the Earth won't get as warm. And then you say, well, what else happens? And I said, well, I don't know, we might not have the monsoons in India. And I said, well, maybe having the monsoons in India was really the thing we should have tried to achieve, not the thing we're giving up. And so you have to have that conversation about whether the goal of lowering temperature is even the right goal. So these are things that I think will happen because people consider geoengineering, which makes it really interesting. I think almost all of the ideas that are out there that have been listed and people have looked at will be trashed. They will turn out to be no good. They all have, the world has a way of pushing back when you poke it most of the time. So, for example, people have talked about brightening clouds, spraying seawater up in the air, and then you get cloud nucleation around these salt particles, and that would supposedly make the clouds whiter on their top, and that would reflect more radiation. Well, a lot of the simulations and observations show that if you get a cloud that's brighter over here, it's sucking moisture and things out of the area next to it, which gets darker. And so it's hard to actually get it exactly right. So the net effect is that you're going to reflect things. And doing it at scale. Can you really make this method work completely at scale? Or doing it without negative impacts, like changing the rainfall patterns. So I think there's very, very little known. We're really at the beginning of this, and we need to think a lot more about it. Well, I think there's a whole area of engineering, if you like, or management, if you like, that's not getting a lot of attention that should, and that's we could call radical adaptation or regional geoengineering. So, for example, we know that we're going to have a really hard time if we lose Arctic ice. That could have a major effect on a lot of other things. For example, if the Arctic ice is gone, then the ocean waters in the Arctic warm up. If the ocean waters warm up, they start to melt the glaciers in Greenland. That starts the process of sea level rise. So there's more, these chain reactions and feedbacks that are very dangerous. So the idea that you might take special action to increase the albedo in the Arctic in some way, maybe only during the summer, for example. Maybe you would use aerosols in the lower atmosphere in the Arctic just in the summer when it's melting, just to stop it, to slow it up. Those are, maybe pie in the sky ideas, but again, I don't think we've begun to think about them. We haven't really begun to think about how we might control certain weather patterns that are really exacerbating our climate. And so that kind of thought isn't happening. But I think that will actually probably be more likely in the sense it's kind of an extension of weather modification, which we already do. And so those kinds of things will also be more likely in terms of their geopolitical capacity. If Australia decides they want to do some perturbation to stop their droughts and floods, that's more local. I think it's much more likely that it'll happen than the whole world get together and decide that they're going to put aerosols in the stratosphere. I work on the energy system. So we've just completed a study for the state of California, which tried to analyze whether or not we could reduce emissions by 80% by below 1990 levels by 2050, which is the law in California by executive order by Governor Schwarzenegger, signed it in 2005. So that is a huge leap. It's like 90% per capita reduction in emissions from today. So we looked at how you could do that, and we designed a logical study, not a projection of an economic study, but was there where do we stand from a technological basis? And what we found was that, what we decided is that you would take 4 steps, because you don't want to burn fossil fuels. So the first step would be that you make everything as efficient as possible, and then you use the same amount of, or use less energy to do the same amount of work. The second step is to electrify a lot of sources of where we've formerly been using fuel, try to use electricity, so electric cars instead of gasoline cars, because it's easier to get the carbon out of electricity than it is out of mobile sources. And then the third step would be to choose an electricity system that didn't produce carbon dioxide, and we had 3 ways to do that. One is nuclear power, renewables, and the other is carbon sequestration from fossil fuel generation. So you capture the carbon dioxide from the flue gas and pump it underground. And then you're still left with a demand for fuel, because there's some things you can't electrify. Can't electrify airplanes or heavy-duty transport. And so all those things that are left turn out that we'll be using about 75% of the fuel in 2050 that we use today, even though we take all these measures. And we'll have to produce twice as much electricity as we use today because of economic growth and because of this problem. So what we looked at was, what are the ways in which you could get this electricity? What are the ways you could get the fuel? So the things that come out in the study is that if you tried to get all this electricity from renewable energy, that you still have a problem because the wind doesn't blow and the sun doesn't shine all the time. And if you have no base load, you really have a problem, because you end up firming, what we call firming the power. In other words, when the wind doesn't blow and the sun doesn't shine, or you're ramping and things like that, you have to use natural gas. There's no other way to really do these long periods. You can do some with hydro, and we can have some batteries, but these long periods when, like at a week at a time, when the wind doesn't blow in California, you would have to end up using natural gas. And we looked at that and said that, if you did that, the emissions would be about the same order of magnitude as what you were trying to get down to for the whole economy. So we believe that the importance of nuclear power is that you have a reliable source of baseload power. And we think that California will have to either, if California decides to do this renewable energy, they're going to have to commit to a very strong program of grid modification and solving this intermittency problem, which they don't link. In other words, right now we have a portfolio standard, but they don't link it to solving the intermittency problem. So that would have to happen. The alternative is the baseload problem, is to pick a baseload. I mean, you look at, compare and contrast what's happening in Sweden and Finland with what happened here, and the way in which they handled the institutional management of their nuclear waste problem compared to what we did.
Tell us about that.
Well, first of all, they started by having a referendum in Sweden in the mid-'80s, which said we're not going to have nuclear power anymore, we're just going to manage our waste, and that's it. So they decoupled the waste problem from the power problem. In the United States, we took waste canisters and put them underground, shoved them underground, and said, see, we can put it underground, now we can have nuclear power. So we immediately coupled those two problems, making the nuclear power industry then feel that they had to have this waste storage in order to move on, and so that created a lot more tension. Then in Sweden, we developed a huge program of saying what the criteria was for storing nuclear waste. You know, what the site should look, what characteristics the site should have, and how to negotiate with the population. And what we did, and so they then looked for sites and sorted them out and picked two or three that were the best, and then they actually created a competition between these communities, and whoever lost that competition got a lot of money. So they had some way to encourage people to go after these jobs and the economic benefit, but even if they lost, they knew they would get money, so they entered the competition. In the United States, we said, here's where it's going to be, now show us it's okay. And we actually filed the application before the criteria for saying whether it was safe were completed. So the application was, we had the cart before the horse in every single way. Part of the environmental movement has been moving towards nuclear power with, say, people like Stuart Brand or I can't remember the guy's name. He's the head of was the head of Greenpeace. Was one of the first. Patrick, something, I can't remember his name. But and more people are coming over. But there's still a strong component of environmentalists, Union of Concerned Scientists, for example, who are still really concerned about safety. They still think safety is a key issue. There are a lot of people who think that the waste is a key issue. There's people that feel that the institutional issues are unmanageable, that we just simply won't be able to manage the institutions. And I'm more sympathetic with that. I think that is the case. But the safety issues, I think the numbers don't add up. I mean, nuclear power is per kilowatt is, I think, if not the safest form of energy on any measure you want to pick. So that I don't think it holds up. I don't think the safety issue holds up. But they can play into people's dread of nuclear power. I think one of the things is the people that are saying that the risks of climate change are overblown, who are still supporting nuclear power, one of the things that they're looking for is this sweet spot where you can support the choice for more than one reason. So with nuclear power, for example, let's say we electrify a lot of cars and we build a lot of nuclear power plants. Then we don't have to import as much oil. So there's a security component to it. Or the fact that we have to use a lot of oil, we have China's putting millions of cars on the road every month, and the supply of oil is just not going to go up that fast. So we have demand going up rampantly and supply not going up very much. So the price of oil is going to go up. So people who really are worried about the economy could get on board with nuclear power and electric cars. And so I think what this group is largely about is trying to find more technical sweet spots that solve a lot of people's problems so people can get on board and move. We can make choices and we can change. I think that's a very valid way to go. And it's a good point with nuclear power that you can get it on but it's not a slam dunk, because as you proliferate nuclear power around the world, the question is how do you do that without causing a problem with proliferation of nuclear materials? So that, it has another side to that story. It's a complicated story. the conversation about when you say you're not going back to nature, when we've said that that's not a valid goal anymore. And they started to talk a little bit about, okay, are we now going to live in a garden, for example? This is something we've nurtured. So, I could have an English garden, or I could have a wildflower garden, or I could have weeds in my garden, which is what I have. But, the conversation of, in some more detail about describing the earth in a way that it's something that we want to achieve. And whether everybody agrees on it or not, to me, isn't important. One of the guys that I work with in geoengineering says that he's very interested in preserving nature. We haven't had an in-depth conversation about what that is, but he takes long trips in the wilderness, and he's very, very anxious for him to be able to continue to take long trips where he sees no people and is approached by polar bears in the Arctic, and he just wants that kind of experience. And part of what he's doing, what his goal is to have that. Other people will talk about a world where everybody has enough to eat. I think a lot of these aspirations have to be discussed in a way that reflects or at least is involved in what do you have to do to achieve that? What are the things that have to happen to achieve these goals? And how many of them do have sweet spots, like we talked about in a minute ago? We have a sweet spot where nuclear power, for example, might appeal to environmentalists and to security people and to people who are worried about the economy. So if that's the case, that you can find more sweet spots and make some decisions. So expanding the sweet spots and talking about having the conversation about what it is we want. I think a lot of times what we do is we don't talk about what our goals are, but we talk about what we're willing to do. Mm-hmm. And I think that conversation we know how to have. We know how to have that. But I think if we shared a bit more about our aspirations, I think we could be more coherent. And maybe we need to be more coherent about our decision making, because we're not making decisions of any sort. A wonderful story about soldiers lost in the Alps in World War II. And one of them found a map in their pocket, and they used the map, and they got out of the Alps, and then they looked at, got back, and they found out the map was for a different part of the Alps. But the point was really that they made decisions, that they became coherent by having this map. And so even though they didn't actually really know where they are, and we don't actually know where we are, they could move. And if you don't make any decisions, then you stay lost. And I think that's a part of the analogy that I'm talking about.